What's up everybody, welcome back. So next part in the AI guard videos, and today we're going to expand our behavior tree a little bit more. So we're going to make sure that if the guard doesn't find anything in the investigation spot, that he's going to go back to his original guard spot, and he's going to go back to the idle state as well. And we're going to make functions for the behavior tree so we can change the move speed, and we can also change the AI state from the behavior tree. So that's what we're going to do today. If you like the series and you want to get the project files for yourself to download, then you can become a member of the YouTube channel or a Patreon, and you will get access to premium channels in the Discord and also downloads for this project file and other project files from the channel. If you don't want to become a member, still make sure to check out the Discord. There's also a bunch of free project downloads in there. So let's start today's video. First of all, we want to be able to store and assign the original guard spot to our guard. So at the beginning of the series, we already created a blueprint we can use as a guard spot to indicate the location. So we want to add a variable to our blackboard. So let's go to the behavior folder and open our blackboard. And in here, we're going to add a new object key. So that is going to be our guard spot. And then we want to set it up to be an actor. So on the right side for the key type base class, we want to select an actor. So we can store it on our blackboard. And we also want to be able to store it on the actual guard. So let's go to the guard character. And in here, we're going to add it as a variable as well. So let's create a new variable, and that's our guard spot. So that's simply an actor reference. Actor object reference, and then we want to make this one instance editable and exposed on spawn. So if we decide to spawn a guard through a script somewhere, we can also assign it from the spawn node. And if we place a guard in the level, then we can simply assign the guard spot as well. So that should be good to go. And then we need to do a tiny bit of setup in here. So on event begin play, we want to make sure that we set the value on our blackboard. So let's go to begin play on our event graph over here. So we already make sure we are only executing this part on the server. And then right after we attach the component to component, so that's the weapon, then we can actually set our guard spot. So we don't need to worry about any of that stuff. That was just for testing. So right after this, we're gonna grab our blackboard. So we can right click and get the blackboard. And from here, we can set a value as object. And we can simply specify the name by making a literal name. So let's make a literal name. And that's our guard spot that we just added to our blackboard. So guard spot, make sure the names match. And for the spot, we can simply plug in our variable over here. So get the guard spot and plug it in. Okay, so that's a little bit of setup over here. Now let's make sure that we add it into the level as well. So let's grab a viewport in here. And we already have a guard spot, so we could essentially just move it over here. So you kind of want to make it at this point that they are in the same location. So let's move it into the same location as the guard. And then if we have the guard selected, we can go to the details panel, and over here we have the guard spot variable. So we can simply click the little eyedropper and then select the guard spot from the level. So now this guard is assigned to this guard spot. So that's set up and good to go for testing. Let's make sure we have it saved. And then we need to go inside of our behavior tree. So let's open this one up. And in here we can simply add a few nodes at the end of the loop over here. So basically we're going to replace this wait, and we're going to make sure that from here we are returning to our original guard spot. So we're going to add more logic later, so don't worry about this being a little bit simple. So we want to drag off over here where the current state is equal to aware. And over here we're going to add a task, and that's a move to task. And in this case we want to move to our guard spot. So we can grab the blackboard key over here and simply select our guard spot. And then after we reached the guard spot, we want to rotate to the correct direction. So we're going to add another task in here. And we're going to use our AI rotate towards task. And if we have this one selected, we can use an actor rotation and then grab the guard spot from our blackboard as well. Okay, so this should make him return if this sequence over here ended. So we're currently not actually checking the state of the guard and if he's idle or not. We're gonna get back to that in a little bit, but we should be able to test if this is working quickly. So let's run a little quick test. And let's make sure we get spotted. And now after the investigation of the location, he should return to his original guard spot. So let's see if this is actually working or not. Okay, that looks good. And now he should rotate again as well. There we go. Okay, so that's good to go. That seems to be working. Now, as I mentioned, I want to add a little task or function to our behavior tree so we can change the move speed of our character, or actually the AI character. So we're going to use one of our interfaces for that. And we want to use the pawn interface because the movement component is on the character or the pawn. So let's open up our AI pawn interface and let's add a new function in here. AI set move speed, for example. And let's give it one input, and that's the new speed. That's going to be a float. So we have our interface good to go. Now let's set it up inside of the character first. So let's open our GDR guard character. And we're going to add the interface function. So set move speed. And we can simply grab our character movement component from the components and then set the maximum walk speed. And plug in our float. So if the server sets this, this will replicate. So we don't need to worry about replicating this ourselves. This should work. So compile and save, and that's the actual character. And now all we need to do is create a simple task for our behavior tree. So let's go to the behavior tree again. And in here, let's create a new task. So the blueprint base task, and I'm going to save it in the task folder. So behavior tree task, change move speed. And then in here, we can simply use our receive execute AI event like we did before. So we added the interface to our pawn, so we can drag off the pawn and then set the movement speed, the message interface from the actual interface, the message function from the interface. And from here we can call our finish execute because we are dealing with a behavior tree task. And we want to set it to success over here. That should be good. Now we can make this move speed a variable that we expose. So let's promote it to a variable and call this our move speed. And we're going to make this instance editable so we can set it from the nodes on the behavior tree. So that's the simple task that we need. And now if we go to our behavior tree, then I want to add it over here. So first of all, at the beginning where we are starting the loop to investigate, I'm going to call my task. So over here, call a task and change the move speed. So over here, I simply want to set it back to the running speed. So he will run towards the location where he spotted the player. And right over here, before we are moving back to our original guard spot, I'm going to make him walk. So I'm going to lower the move speed over here. So let's drag it in again, call our change MoveSpeed task. And over here, let's set it to something like 120, maybe 140, something like that. And then compile and save. So now if he returns to his original guard spot, he should be walking. And if he spotted a player, he's going to run towards that location like he used to. So let's check it out quickly. So that was the running, that's good. Let's make sure he doesn't see us. And now he's actually returning slowly to his original location. So we have something to play around with the move speed as well. Not the most important thing, but it's just funny to have it in there. And the next thing I want to do is make sure that we can also change the AI state from our behavior tree. And then we're going to clean up the behavior tree as well to make sure that the returning to the guard spot also triggers the idle state again. So let's make sure that our guard can return to the idle state after the aware state. And we're switching states inside of our controller. So we're going to use the controller interface for that one. So from the behavior folder, the AI controller interface, let's open it up. And in here, let's add a function. So we already have a function on the actual AI controller that's called AI change state. So for this one, I'm going to call it BPI AI change state. So we know which one is the interface. Change state, and we're going to add an input, and that's the new state. And for that, we can use our AI states enumeration that we created earlier in the series. So compile and save, that's the interface good to go. And we want to set it up inside of our controller. So let's open up our AI controller. And we want to add the interface function in here. So let's double click it, AI change state. And all we want to do for this one is call the change state function. So that's over here. So I'm going to drag it over here. And then we can simply call that. So AI change state. And we want to pass on the new state. So that's good to go. And now we also want to create the actual event that we're going to call if we are returning to idle state. So let's create a new custom event over here. We already have an event for aware state and combat state. So we're going to do the same thing over here. Create a custom event, and this is called start idle state. And the first thing we're going to do is set our current state. So let's drag that one in and make sure we set it to idle. Then we're also going to update the state on our blackboard. So we want to get our blackboard in here. We can use the variable over here because we are on the controller, and then set a value as an enumeration. Plug it in over here. The key name is the literal name, and that's our current state, if I'm not mistaken. So current state. Let's double check it on our blackboard. Why not? So blackboard over here, current state. Yeah, that should be good. And then we can plug in our state over here. That should work. After we did that, we want to make sure that we update our perceived times array. So over here, in this event where we actually update the times, if we go into aware state, we're setting all the perceived times to -1 to make sure that we can remove the widgets, but we're not actually destroying them, we're only making them invisible. And if the AI goes back to the idle state, we want to reset these values so he can start perceiving other actors again. So that's what we're going to do over here. We're going to grab a for each loop. And we can plug in all of our perceived times. So we can simply check if they are less than 0. So if we set them to -1 or not. So let's drag off the array element and look for less than. So we can simply say is less than 0. That should be good. Plug it into a branch over here. And if it's actually less than 0, then we simply want to set it back to 0, so that will make it that we can start counting again. So we can grab the perceived times array and set an array element. So this goes into the true bin. We want to grab the index from the array index over here and simply set it back to 0. So that should be good. For now, that's all we're gonna do over here. We can expand this a little bit later, but that's not too important. We do want to make sure that we add a call to this event in our change state event. So we're gonna go to AI change state. If our current state is aware, and we're gonna go to idle, then we want to call our start idle state. So call the event over here. Like so. Okay, we can compile and save that one. Now I need to grab my notes in here quickly. At this point, we want to go into the behavior tree again. And we can simply go all the way to the end for now. So after the AI rotate towards, before the wait completely at the end, we're gonna change the state, but we need to create an actual task to do that. So again, we're gonna go to task and create a blueprint-based task. I'm gonna store it in my task folder, and this is going to be a behavior tree task, AI change state. So we're gonna grab the event execute AI, and in this case we added the interface to the controller. So we're gonna drag off the owner controller, and we're gonna call our BPI AI change state. So make sure we call the actual message function over here. And after that we want to finish execute because we are using a task on our behavior tree. So finish execute, and we're gonna turn it into a successful task. And to make sure we can set the state from our behavior tree, we're going to promote this to a variable. So our new state, and make sure this is instance editable as well. So that's the simple task again. Now we can go back to our behavior tree, and we can simply call it over here. After we rotate it towards the guard spot rotation, we're going to call our task to change the state. And in this case, we want to set it to idle. And if we do this, then this node over here will actually change the condition. So we have the onResult change will abort itself, and the condition is no longer equal to aware. So this wait at the end over here for 10 seconds will not be executed because our state will change, and then this node will abort and it will start evaluating the tree from the beginning again. Okay, so that should pretty much work. So if we check this in game, then he shouldn't only return to the guard spot, but also go back to the idle state where he's playing the random idle animations. And we can actually grab our gameplay debugger and then enable our behavior tree. So that's already enabled. And now we can also see our blackboard values. So we can see the current state is now aware, and that should turn back to idle if he's back at his guard spot. Exciting moment. There we go. And now our current state is back to aware. Idle, I'm sorry. So if I walk back into his sight range, he can now start perceiving me again as well. Okay, so that part seems to be working. One thing I want to do right now is clean up our behavior tree a little bit, because the way we have it set up currently isn't really effective. Let's go back into our behavior tree, and currently over here, after this loop, I want to disconnect everything except our change state. So this part doesn't really belong inside of the aware state loop. Over here we are returning to the guard spot and things like that. So we're no longer really inside of the aware state. So what I want to do over here if this loop is finished and there's actually no change to a combat state, and if that happens, it will simply abort the node and execute other logic that we didn't create yet. But if this actually runs all the way through and the AI does not spot an enemy, we're simply going to change the state back to idle. So as I mentioned previously, that will also make this node abort and it will re-evaluate the tree. So what we're going to do now is add a sequence all the way at the beginning. So before our current state is equal to idle. So let's drag off here and add a composite sequence. And in here we're going to add two conditions as well. So the first one is simply check if our state is idle. So let's add a decorator blackboard. We're going to select it and we're going to make sure that our current state over here is equal to idle. And then we also want to add is at location check. So if we right click, go to decorator again, we actually have is at location. And in here we can simply assign our guard spot location, and you can enter an acceptance radius over here, so it has a little bit of tolerance if you would like to. So this will simply check if we are at our guard spot already or not, and if not, we're going to move towards our guard spot. So then we can grab the nodes that we disconnected from here and move them to the beginning. So if we're not at our guard spot, I'm going to change the move speed to 120. We're going to move towards our guard spot and we're going to rotate towards it. There's one call I want to add in between here, and that's actually clear focus. So we don't really need it at this point, but later we do, and then we probably forget it. So right now I'm going to call our behavior tree task, and then I think... Oh, really? Oh, we didn't actually create that yet. I thought we did. Okay, well, I will make sure to add a note. It's not really needed at this point, as I mentioned, so we're gonna get back to that when needed. So what will happen now? Over here, we're gonna change our state to idle. It will make sure this node gets skipped because this entire condition fails. We will go back over here, check if we are idle and at our guard spot. If not, move towards it and then go back to guarding. So if we test this, then that should work in the same way as it did before, but it's just a little bit more logic to set it up like this. There we go. So he's going to investigate our location. Run the loop twice. So let's grab the debugger, why not? We're still in aware state. And now we are at idle, but we're not returning to our guard spot. So something did mess up. I'm gonna check what's wrong and get back to you guys. Okay, I'm an idiot, as usual. So inside of our behavior tree, the is at location check. So we're checking if we are at the location, and we are not, so this will not execute. We need to make sure that we inverse the condition over here. So if we are not at the location, we're gonna move towards it. So that actually makes a little bit more sense as well. So let's test again to make sure, and let's make it a 2-player game, why not? This should all work fine in multiplayer as well. So let's move this guy out of the way a little bit, and then make sure our client gets spotted. And make sure we run out of the way. So investigating the location with 2 loops. And this time we are returning to the idle state and also returning to our guard spot. So you can see the move to guard spot is executing on the left side on the behavior tree. And right now we are executing the wait in between the play idle break animation. So that part is working, and we have our behavior tree set up a little bit better than we did a couple of minutes ago. I think I'm going to leave it at this for the episode, and in the next episode we're going to continue by adding the awareness icon and then also adding hearing perception and possibly the damage response. So we're going to keep expanding this with new stuff and make it cooler and cooler. Hope you enjoyed the series. If you did, please consider leaving a like, and I'll be back soon for more. Talk to you later, guys and girls. Bye bye.